The Foundations of Geometry by David Hilbert.
Chapter 5, Desargues' Theorem. Section 30, Significance of Desargues' Theorem. If, in a plane geometry, axioms group 1, 1 and 2, group 2 and group 3 are all fulfilled, and, moreover, if the theorem of Desargues holds, then according to sections 24 through 28, it is always possible to introduce into this geometry an algebra of segments to which the laws 1 through 11, 13 through 16 of section 13 are applicable. We will now consider the totality of these segments as a complex number system and construct upon the basis of this system a geometry of space in accordance with section 29, in which all of the axioms of groups 1, 2, and 3 hold. In this geometry of space, we shall consider only the points x, y, and 0, and those straight lines upon which only such points lie. We have then a plane geometry which must, if we take into account the propositions established in section 27, coincide exactly with the plane geometry proposed at the beginning. Hence we are led to the following proposition, which may be regarded as the objective point of the entire discussion of the present chapter. Theorem 35. If, in a plane geometry, axioms group 1, 1 and 2, group 2, and group 3 are all fulfilled, then the existence of Desargues' theorem is the necessary and sufficient condition that this plane geometry may be regarded as a part of a geometry of space in which all of the axioms groups 1, 2, and 3 are fulfilled. The theorem of Desargues may be characterized for plane geometry as being, so to speak, the result of the elimination of the space axioms. The results obtained so far put us now in the position to show that every geometry of space in which axioms of groups 1, 2, and 3 are all fulfilled may be always regarded as a part of a geometry of any number of dimensions whatever. By a geometry of an arbitrary number of dimensions, it is to be understood the totality of all points, straight lines, planes, and other linear elements for which the corresponding axioms of connection and of order, as well as the axioms of parallels, are all valid.
The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice. This ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Renholt. Programming and illustrations by Jim Renholt. 2019. Portrait of David Hilbert by Rita Ray Renholt. Thank you for listening.